First condition we have to think about is it continuous? And for the continuity condition, remember that is really about, do you have a denominator, do you have a radical, or do you have a natural log? And in this case, tangent of 2 pi x, it's not in your face that you have a denominator, but of course we know that tangent of 2 pi x is the same as sine 2 pi x over cosine of 2 pi x. So we do have a denominator here. So this function will be continuous if or provided the denominator is not equal to 0. So the function will be continuous if cosine of 2 pi x is not equal to 0. So we need to solve this equation and see if there are values for x that are also in the interval of interest here. So if you think about solving this equation, you're going to take your 2 pi x and you're going to let theta be equal to 2 pi x. And this is how we deal with this multiple angle trig equation. So the 2 pi x here is not just x, it's 2 pi x. So what we refer to this as is a multiple angle trig equation. And the way that we deal with that is we let theta be equal to 2 pi x. And what that does for us is now the multiple angle trig equation looks like cosine of theta is equal to 0. And we certainly know how to solve cosine of theta is equal to 0. We just look on our unit circle for where the x coordinate is equal to 0. So if you think about on your unit circle, the x coordinate is equal to 0 at pi over 2, and it's also equal at any n pi integer value of that. So you would have to say at pi over 2 it's certainly equal to 0, but at 3 pi over 2 and continuing. So what you would do is you would say that your x coordinate is equal to 0 at pi over 2 plus n pi. So that means the solution to cosine theta being equal to 0 would be that theta has to be equal to pi over 2 plus n pi. Okay, now once we get this theta is equal to pi over 2 plus n pi, then we got to convert it back into what our original variable was. So we let theta be equal to 2 pi x, so now we're going to substitute back in that theta is 2 pi x. So in for theta, we're going to put our 2 pi x, and then that's equal to the pi over 2 plus n pi. Okay, so again, the theta here gets substituted again. So we substitute once at the beginning to convert it from 2 pi x to theta, and then we substitute again. And now we need to solve for x. So to solve for x, I'm going to divide by 2 pi, and then divide each of these terms by 2 pi. So this will get divided by 2 pi, and this will get divided by 2 pi. So that will give us x is equal to, the pi's cancel out, so we get 1 over 4 plus, and then these pi's cancel out, n over 2. Okay, now we are interested in where this x is in a particular interval. Namely, we are interested in on the interval 0 to 2. So what we have to do is we have to run this in from n is equal to 1 up to the end of the interval. So if n is equal to 1, then, well, first of all, if n was equal to 0, if n was equal to 0, we would have x is equal to 1/4 plus 0 over 2, which would give us 1/4. So one of the numbers that is a problem here for which the function is not continuous is 1/4. And honestly, like, you can sit there and think about n is equal to 1, n is equal to until you get to the end of the interval. But as soon as you know that this 1/4 is not going to be, is going to be a place where it's not continuous, you're done. You can say that the mean value theorem does not apply on this interval. So again, there are more. You can run through all the different n values, but you can say the mean value theorem does not apply because f is not continuous on that closed interval from 0 to 2. And you could delineate that it is not continuous at x is equal to 1/4, x is equal to 3/4, 5/4, and 7/4. So you could actually find those values by letting n be equal to 1, 2, and 3. Okay?